All right, folks, if you're here, it's because you tried this on your own and you couldn't figure out. Don't take the easy way out. Let's try this first, because otherwise you won't know how to do it if you're asked to do it again. But here's the step by step. So I've taken this circuit, I've changed the values so that you don't just copy everything. You still have to figure out some numbers. And let's talk about how to solve this. So I need to solve for my total resistance, my total amperage, the voltage at 1, the voltage at 2, and the voltage at 3. So in order for me to solve total voltage, remember we have to deal with totals, right? So the first thing I need to do is deal with my total resistance. R1 for a series circuit, or R total, is equal to R1 plus R2 plus R4, so on and so forth. So I've got a 330 plus 1500, it's kilo ohms, plus 450. So RT equals 350 ohms plus 1500 ohms plus 450 ohms. So that's 800 plus 1500 is 2300. RT equals 2300 ohms, aka 2.3 kilo ohms. Okay. All right. So now that we have that total, we've got a total applied voltage. We know that. We've got a total resistance. Now we can find our total amperage by using our Ohm's law. Ohm's law is this guy that you've written down elsewhere. If I want to find my amperage, it's going to be my voltage divided by my resistance. So IT equals VT over RT equals 6 volts over 2300 ohms. Okay. All right. 6 divided by 2300 equals 0.00260, which is, remember, move the decimal place. So our total amperage, our total current is 2.60 amps. All right. Now we have to solve for voltage at each one of them. Okay, so what is true about amperage in a series circuit, about flow? What's true about flow is that it's constant. No matter where you are in a series circuit, the flow will be the same. Okay, so we figured out that IT equals 2.60. Oops, I meant to put milliamps. Okay, which is 0.0026 amps. Okay, if we're going to use that later on. Now we have to do voltage at 1 is going to be voltage is amperage times resistance, okay, which is going to be, our amperage is always the same, 0.0026 amps times 330 ohms equals 0.0026 times 330 is 0.858 volts. voltage at 2. Now, your numbers are different, of course, right? I think you probably get the point here. So I'll do one more. Voltage at 2 is, again, whatever our amperage was. We got 3.9. And while you weren't looking, I did this one. All right, now KCL, our Kirchhoff's voltage, or KVL, sorry, says that our total voltage, or all of our voltages at each component, will equal the applied voltage. So 0.858 plus 3.9 plus 1.17 hopefully will equal 6 volts. Let's find out. And it's 5.93. 0.93. Now remember, you might be off a decimal point or two, okay, which is similar to 6 volts. Cool. All right, so that's the first one. We solved for all the things we were asked to solve for. Now we're in the second one. All right, so again, I've changed numbers so that you can, apply your values, right? Okay, so we're solving for RT, IT, and the amperage. So here's what's going to be true, again, about a parallel circuit is that the flow will change at each one of these components, and this time the voltage will remain the same. So it will be 9 volts at each one of these components. But first, we're going to have to get an I total to know what the current is, and in order to get that, we're going to have to get the whole resistance. So remember, our total resistance for a series circuit equals 1 over the reciprocals of each one of these things added up. Okay, so our RT equals for this one, which is again what you're not doing, let me think about how I want to do this. I think I have a -1 button there. There we go with an inverse. So we can do we've got a 7.1 kilo ohm, a 5.3 kilo ohm, and a 3.9 kilo ohm. All right, so that's 7,100 to the -1 plus 5,300 to the -1 plus 3,900 to the -1. And that gives us a value that we're then going to take our answer. I think I can just put to the -1, enter, and that's going to get us 1,706.68 kilo ohms. 1,706. Again, your values are different because I'm just showing you how to do it. 0.68 ohms. Now, we could write that as kilo ohms, but I need this for other things also. So we're going to leave that at that right now. All right, so my Ohm's law says that my total voltage, my total resistance, Voltage divided by my total resistance will get me my flow. So my 9 volts divided by 1706.68 will get me my amperage. So my IT equals 9 divided by 1706.68. 9 volts divided by ohms equals 5.27 amps. 5.27 milliamps. Sorry. Milliamps, or 0.00527 amps. All right, you should end up probably with some milliamps in there. Also, now that we know that, we can get our voltage total. We're going to need our total voltage to know what the voltage is at each point. So my voltage total equals my voltage equals my amperage times my resistance. My total amperage, 0.00527 amps times my total resistance, 1706.68 ohms. And that's going to equal my total voltage. So I got 0.994. Oops, sorry, 8.994. Oh, I don't know why I did that. I already have total voltage over here. That was silly. All right. We have 9 volts. Oops. All right. So we have 9 volts here. We got 9 at each one of those. If you are watching this, I hope you went, why is he doing that? We already know the applied voltage. Oh, well. All right. Now we need to find out what each one of the amperages were. For a second, I thought we were solving for voltage, and I don't know why I was thinking that. So we need the amperage at 1, aka flow, our amperage at 2, and our amperage at 3. So amperage is always going to be voltage divided by resistance. The voltage is always the same. So the voltage is always going to be 9 volts. So we can always set these up now. It's always going to be 9 volts because in a parallel circuit, voltage is always the same. And now we've got divided by our resistance, which at one point is 7,100. Second point is 5,300. And third point is 3,900. And to keep clean with units, I put in my units. And after working it out, these are my values. I kept quite a few decimal places because when we get these small numbers, we got to have a few more to see if that works out. Now, our KCL says that our total flow should add, or our individual amperage should add up to our total amperage. So that means that our 0.001268 plus 1698 plus, I'm going to run out of room, 307 equals 0.005273. 0.00527. 0.00527. Check. Cool. Works out. All right, guys. So there's how to solve each one of those circuits. Hope it worked out for you. Have fun. See you later.